Okay. Now, I think we know the data here. There are two sections. One is steel and one is copper. The length is given 500 and 50 mm 30, and the diameters are given 30 mm and 20 mm. And here, at this point, this load is acting at this point. This load is acting at this point. So we have considered this section as 1, we have considered this section as 2. Let us find out what is the load acting on each of the sections. And there is one fixed end here. Okay? Let us not worry about the fixed end. Let us see what is on the other side. Okay? It becomes easy for us. So we see the end, the section 1. And let us see, first thing what you have to do is you have to write an arrow here. But this arrow is acting in the ultra direction, which means it is compressive. It is compressing section 1. But I have written arrow which is actually showing extension. So this is opposite to that. So I should write it as minus plus idre. Suppose in part 1 suppose if it is elongating, then it should be plus. Nimge finally you are trying to find dl. Nimge yavag length ಜಾಸ್ತಿ ಆಗುತ್ತೆ, expansion is there. Now this is trying to compress, so it should be minus. So every time, though now you should not write like this. The first thing you should do is you should draw an arrow mark facing outwards, which means that this is acted upon by tensile, but it is not acted upon by tensile, it is acted exactly ulta of tensile. So I should write it as minus 10. Okay, please keep this in mind. Once it is done, minus 10 ಅಷ್ಟೇನಾ, ಇನ್ಯಾವುದು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರೋ ಅದ್ರ ಮೇಲೆ. So you have to see that if you see here, there are two forces acting on this left hand side. One is actually 10 kilonewton, which is actually going inwards, and the other one is which is actually tensile, which is 5 kilonewton outwards. So what is the total load here? It is minus 5 kilonewton. It is minus 5 kilonewton. Obviously, even on the other side, it will be minus 5 kilonewton. Okay? So once it is done, you can definitely find out what? Change in length for section 1. So change in length for section 1 can be found out. So dl1 is equal to p1 l1 a1 e1. So what is the load acting on this section 1? Minus 5 kilonewton multiplied by what is the length? 50 mm. And area, some people what they do is they actually find out this area separately. If you want to do that, you can do that. So pi d square by 4. So pi d1 square by 4. So 3.14 into d is 30 mm whole square divided by 4. What is the answer?
Minus 1.7.
Minus area.
706.9.
Area. 706.95 mm square. Idu d square idella mm square agutte. So area, why I am doing this? Why did I do this? I can write, if the area can be people may actually go wrong. So sorry, at least area sari idre area dara one mark sigutte. So I done this 706.95 mm square multiplied by E1. E1 is to steel ge. So steel ge usually 200 GPa anta ಕೊಟ್ಟಿರ್ತಾರೆ. So 200 GPa, copper ge 100 GPa anta ಕೊಟ್ಟಿರ್ತಾರೆ. So 200 GPa. So 200 GPa is 250 to the power of 3 Newton per m square. Is this seen in the screen?
Yes, sir.
Okay. So substitute these values, you get the answer. So here n cancel ಆಗುತ್ತೆ, m square cancel ಆಗುತ್ತೆ, Newton cancel ಆಗುತ್ತೆ, ಕೊನೆಗೆ ಏನು ಕೊಡೋದು? mm. So you get dl1
minus 1.768.
minus
1.768.
1.768 mm.
Sir, into 10 to the power minus 3.
Into 10 to the power of
Minus 3.
minus 3. Very, very small deformation. Very, very small deformation. This is mm. Guys, why did we get minus here? Because this is compressive. It's compressive. Though I actually put this arrow mark outside, but I put this as minus 5 kilonewton, which is actually 10. I mean, which is compressive. So I got this minus. So since I put this minus here, I am getting minus here. Suppose if you miss minus sign here, you will miss minus sign here. So wherever it is compressive, you please put it as minus. Okay. Then you find out what is the load on the section 2. What is the load on this section 2? Now you look at the section 2, you look at one side. Which side is easier to look?
Right side.
Right side. Because the right side has got only one force. So see the right side, what is the force acting?
Right.
So first thing, without even thinking, you put this arrow marks like this. Without even thinking, you put the arrow marks like this. Suppose if it is along the arrow mark, then you put it as positive. If it is against this arrow mark,
Negative.
it is negative. Now what is the force that I should put here?
5 kilonewton.
Let us put it as plus 5. Plus 5. So plus 5 kilonewton. So once you have done this, so once you know the load on this is plus 5 kilonewton, then all the details about this part 2 is given. So dl2 is equal to P2, L2, A2, E2. So you can substitute these values here. So what is P2? So plus 5 kilonewton plus 5 into 10 to the power of 3 newtons multiplied by length, which is actually 30 mm. And here area 2 is not found out. Let us find out the area 2 here.
314.2.
So you can you found out it. How much?
314.2.
314.15 or 2 or somewhere. You found out here and substitute this 314.15 mm square, and then E2. Since it is copper, it is 100 GPa. 100 GPa, 100 into 10 to the power of 3 Newton per mm square. You substitute this, you get some answer. What's the answer?
4.77 into 10 to the power minus 3.
4.77 into 10 to the power of minus 3 mm. Otherwise, if you don't want to write like this, you can write it as 0.047. You actually shift this by 3 decimal places. 1, 1 0, one more 0 like this. You can write like this. You can write like this. Suppose if you don't want to write like this, very, very small deformations. So then, if they've asked total elongation, then total elongation is dl1 plus dl2 plus dl3, which is the sum of, sorry, there's no dl3 here. So dl1 is how much?
1.76.
1 point minus 1. So plus, okay, and plus 4.77 into 10 to the power of minus 3. What is it? 0.
0.02.
Illi.
3 into 3.006.
3.002
into 10 to the power minus 3.
3.001, sir.
Okay, around that value.
3.002.
3.02 or 03 or whatever. Okay, something like this. So the problem could be solved like this.